Hi guys, welcome back to a digital masterclass on IIT JEE. So let's begin with today's series. And the topic for today's series, which I've chosen, is sequence and series. And the two questions here are as follows. This is the first question. Let's begin with this. So compute the convergence sum to infinity for the given arithmetic geometric progression. Okay, so if you look at this series, it's a combination over here. If you have a careful look, s is equals to 1 plus 2 by 3 plus 3 by 3 square plus 4 by 3 cube plus it goes on up to infinite. So what can be the sum of this series and how you are going to evaluate it within the given time frame in the exam setting? So what we'll be doing is we are going to look at it and how we'll develop the line of thought to solve this question. If you look at the numerator part is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, a plus 1, an arithmetic progression with a common difference of plus 1. If you look at the denominator part, it's 1, 3, 3 square, 3 cube, 3 raised to the power 4, 3 raised to the power 5, 3 raised to the power n. A geometric progression with a common ratio of 3. Now how do we proceed? Can you think of this thing now how to proceed with this? So if you look at it and if you think like what can be done in this question, okay, if I rewrite this series again with a shifted way, and if I, let's say, divide this thing by 3, okay, what it becomes? It becomes 1 by 3 plus 2 by 3 square plus 3 by 3 cube and 4 by 3 raised to the power 4, and it goes on and on and on up to infinite. Now why did I do that? Because once I did that, and if I subtract these two equations, s minus s by 3 is 2s by 3. Now I'll shift the way they are. I will just subtract 0. It's 0 plus the entire series. So now I will subtract 0 from 1, which is 1. I'll subtract 2 third and 1 third from 2 third, which gives me 1 third. I'll subtract 3 by 3 square from 2 by 3 square. The denominator is same and the numerator is subtracted to 1. So it becomes 1 by 3 square. 4 by 3 cube over 3 by 3 cube is 1 by 3 cube. So how is it helping us? It is giving me an infinite series, an infinite geometric progression with a common ratio of 1 by 3. Now it is simpler to sum. That's why, how do you think to solve it in the examination? You need to simplify this thing, this entire series, whose sum you already know how to calculate. You don't know how to calculate a series like this. The numerator is following an AP progression, and a denominator is following a geometric progression too. So you don't know of any formula for that, but you know separately how to calculate the sum of an AP and a sum of a GP. So what you did was you just divided it by 3, and then you rewrote the entire series, shifted by 1 unit, and then you subtracted both the equations. You got 2s by 3 equals to 1 plus 1 by 3 plus 1 by 3 square, and a simple geometric infinite geometric series whose sum is, you know, if first term is a, it is a over 1 minus r, where r is the common difference. So first term is 1 over by 1 minus 1 by 3, 1 by 3 is the common ratio, so it becomes 1 over 2 by 3, which is 3 by 2. Got it? So S is equals to 9 by 4. This is the answer to this summation series. Simple. Got it? For any doubts, you can comment below. Let's go to the next question, the advanced one. Okay, the question is over here. Summation of a series, summation n over n4 plus n square plus 1 from n is equals to 1 to infinite. It looks complicated when you at first glance, this thing looks so weird. Like, what the hell can be done here? But if you look at the denominator, what all can you do? See, if you just plug in the value 1, 2, 3 here, it will be 1 over 1 plus 1 plus 1. 1 over 3 plus 2 over 16 plus 4 plus 1. So 21. 2 over 21. So it will be a weird looking series whose sum you don't know. So now we know that this thing is not going to work. So it needs some kind of manipulation. So if you look at the denominator, what can I do? I'm just going to factorize the denominator and rewrite the denominator and see what happens. This is the series. So what am I going to do here is n upon. Now I'm going to write n 4 plus 2n square plus 1 minus n square. Why am I doing it? Because it gives me this thing sums up to n square plus 1 whole square minus n square. This summation sign 1 to infinite is over there. Now if you have a look at it, it becomes it is giving me something sensible, right? Now a square minus b square can be written as a plus b and a minus b, which is n square plus 1 minus n. Okay, I'm writing it in a particular order. It should be n square plus 1 plus n square plus 1 minus n. So that's what I wrote. So now what am I getting out of doing all these things? What can be done here is, it is, if you look at both these guys and if you look at the difference of these two, it's coming out to be 2n. And what's in the numerator? Numerator has n. So if I divide the numerator by 2 and multiply by 2, so this 2n can be replaced with this minus this. Why am I doing it? So that I have a cyclic series minus n square minus n plus 1. What am I getting out of all these? Now if you look at the numerator, this thing is 2n. Got it? Now if you simplify this series, it is the same series, but now see what it is getting us. 1 upon, if you write them separately, n square plus n plus 1 divided by this entire term, it will give me n square minus n plus 1 minus 1 upon n square. This is minus minus cancel, n square plus n plus 1. Got it? Now once we have it, it should be easy for you to recognize that it's a cyclic series. What does it mean? It means all the middle term will cancel out, only the first and the last term will be remain. So if I replace, and the series was from 1 to infinite, right? So if I just begin with 1, it is 1 upon 1 minus 1 plus 1, which is just 1, minus 1 upon 1 plus 1 is 1 by 3. Then n is equals to 2 would give me plus 2 square minus 2 is 4 minus 2, which is 2, plus 1 is 3, plus 1 by 3. And then if I substitute 2 in this form, 1 over 2 square plus 2 plus 1 is 1 by 7. And again, if I write, substitute n is equals to 2 over here, it will be plus 1 by 7. Then it's a cyclic series. All the terms will cancel. The first and the last term will be remaining. Why am I not considering the last term? Because in the last term, the value of n is approaching infinite, which means this entire term will be approaching 0. So all I'm left with is half. So the summation of this series will be simple half. Got it? So this is how we'll be proceeding. So thank you guys for attending the session, for attending this lecture, and let's meet again with some other topic from JEE questions, mains and advanced. So for any details and for joining if you are interested, you may subscribe to the channel. For joining regular classes, you may contact me, mail or call me. Thank you.